Okay. We can get through the first 4 ones and then maybe it'll work.
Okay.
So, example CO2. How many domains does it have?
2.
2. Yeah, because you just have one there, one there. So, how many of those domains are bonding versus lone pairs?
2.
2 bonds.
0 lone pairs.
0 lone pairs. So, what's going to be the angle between those 2 bonds?
Okay, so it's either going to be linear or bent. It depends on how many electrons are the oxygens. Oh, they cancel each other out, so it'll be linear. Right?
Yep.
It'll be linear.
Yep. And you could use the Vesper theory to figure that out, because those bonds, there's nothing else up here or down here, no lone pairs. So those bonds will position themselves to where they're the furthest apart possible,
Okay.
which is going to be linear.
So that's 180.
And so the angle is at 180.
Okay.
Okay,
So when there's 2 domains, will it always be linear?
I think so, yeah.
Okay. So it's pretty serious.
So that's the only one actually with 2 domains, is that one. So yeah, it'll always be linear if it only has 2 domains.
Okay.
The next one we have is 3 domains. Or I shouldn't have said that, I should have let you.
It's okay. I got the domains down. Okay, wait, so in a bent one.
We'll get to that one.
Okay.
It's kind of like the linear, yeah, just the lone pair pushes those bonds down.
Okay.
Because now there is something right here. And so since that wants to be as far away as that as possible, and that,
Right.
it has to push them down. So
Okay.
it becomes bent.
Okay, so there's 3 domains. There's 3 bonds. 0 lone pairs. So, is that 120?
Yep.
120. And I want to say trigonal planar.
Perfect.
So that's just a flat, like,
Yep.
triangle thing.
Yep. Yeah, we could draw these wedge and dash projections, but it stays the same. So
Okay.
both of those do. Okay. Next one. This is
Okay, so that's 3 domains as well. 2 bonds, 1 lone pair, degree. Okay, so it'll be bent.
and your degree will be between these 2.
Only those 2?
Yeah, because this isn't, your degree is the bond angle.
Between?
Just between the
Okay.
bonds.
So when you're doing the shape, there's 2 different kinds of shapes, right? The molecular and the
Electron domain geometry.
Okay, so when you do, so like in this case, we're saying bent. Which was the one where you don't like count the electrons?
That's molecular geometry.
Molecular geometry. Okay, so like technically it's trigonal planar, but we don't really count it. We just,
Yeah,
I mean, like
yeah.
if we were counting the electrons, it'd be trigonal planar,
Uh-huh.
but.
Yeah, because electron domain geometry just looks at this, 2 versus 3 versus 4. It doesn't look at lone pair versus bonding.
Okay.
So yeah, both of these would be trigonal planar for electron domain geometry.
Okay, so the molecular geometry is usually the one you're going for, right?
Yeah.
Okay, so that is bent, and I want to say 120, or, oh wait. Well, okay, correct me if I'm wrong, but I feel like electrons, the difference between the angle between a bond and electrons are different than two bonds. So it'll be a little less than 120?
Yep, it's actually 118.
Okay.
Yeah, because these guys, since they're not confined to a single space, they're free to roam. So they take up more space than just this bond, so it pushes these guys a little closer together.
Okay.